Okay, now there's another aspect of the C string object we also need to talk about, and that's the copy constructor. And this is going to get at a concept called deep copy versus shallow copy. Now, the default copy constructor for an object, like we talked about before, what it does is it does a struct copy. It copies the fields from one object to another object directly. And so the default copy constructor is just going to copy the array pointer from one object into the new object that it's copying into. And so that could happen if we use our C string in a variety of contexts. Like if we pass our C string to a function, then that means we would just hand over a pointer to that same array in memory. Or if we were returning a C string from a function, we would just hand back that same pointer. Or if we were initializing an object from another object, we would let them basically have the same pointer pointing to the same array. And the question is that okay for these objects to share the same array? So this really gets at an issue of, do you want a shallow copy or a deep copy of an object? And this is the terminology we often use, shallow versus deep. So shallow means we just copy the fields. And I've drawn a picture of shallow copy here on the left. So if I have a C string S and a C string S1, and I copy S into S1, then what's going to happen at the end is that the two arrays, and actually, these, you can pretend like this is the same object we've been working on. The fields I had drawn here are a little different, but this concept is the same. These two pointers are going to be pointing at the same physical array in memory. And what that means is that if I use S1 to modify this, to like change the array, then I'm going to change this location in memory. And if I use S to modify the array, it will also change this location in memory, which means S will see changes made by S1 and S1 will see changes made by S. There could be scenarios where that makes sense. But probably for our C string object, that's not what we want. We probably want these to be two different strings that can be managed and manipulated differently. So this shallow copy in which we just allow the two fields to have the same value, which means they're pointing to the same physical array in memory, is probably bad. So the shallow copy, where you just do a dumb struct copy, is a bad idea. What we need really is what's called a deep copy. And in a deep copy, you're not content just copying the fields verbatim. Instead, what I actually do is when I make a new copy here, I make a whole nother array and I copy the contents of the array over as well. So now my new object S2 that's copied from S, it actually has its own array with the same contents as object S. This is a deep copy. And oftentimes when we have pointers inside objects, what we want is a deep copy. It's not always the case. There are some cases where you want to share arrays between objects, or where you want to share pointers between objects. An example is a smart pointer that will actually manage memory for you in kind of an intelligent way. But in this case, it's probably not what we want. And it's definitely not what I want from a teaching perspective, because I want to illustrate a situation where you really need to implement a copy constructor. Okay, so what we need to do is make our copy smarter than what the default copy would be. The default copy would do a shallow copy, but what we need is a deep copy. Okay, so can we use the default copy constructor? No, we don't want each copy. We want each copy to be its own array that can be distinctly modified and destroyed, so we need to make a custom copy constructor. And so here's what our copy constructor is going to look like. Now again, it's a constructor, so it's a function that has the same name as the class. And then the argument to a copy constructor is another object of the same type, so it's a C string object. And we pass a reference to it so that it's efficient and we don't need to make a copy to call the copy constructor. And then what we do is we do everything we need to do to copy the contents of this other object into our new object. So we set size equal to other size. And then we allocate an array of the same length as the array in the other object, right? And we know it'll be the same length because we get its size and we add 1 to it. Okay, and then And then again, we can use this memcopy function to copy the contents out of the other array into our new objects array. And we make it size +1 because size just tells us the length of the content of the string, and then we need to add 1 for the null character. And that guarantees that we copy everything over. Okay, again, what makes it a copy constructor? Well, we know it's a copy constructor because it has the same name as the class. The argument it takes one argument, and that argument is an object of the same type, which means I'm copying from something of the same type into this new object. And we make it a reference so that we don't have to make a copy coming in. And const is optional, but const is just a promise that says we won't modify the thing we're copying from, which is kind of a good promise to make, since you want it to be an actual copy. If you somehow modified the original in the process of copying, that seems like a bad choice in most situations. Okay, so in summary, each C string should have its own array. And in order to guarantee that, when we make copies of the C string object, we need to make sure that it makes a copy of the whole array. So we need to write our own copy constructor to make a deep copy. And this will prevent sharing of the same array that a naive copy would have.